Hello, my name is Ian Miskimin, and I've been lucky enough to be involved in many of the major infrastructure projects worldwide that have a BIM deliverable. This position has given me a good insight and overview into what good practice and where the issues are. This has led me to form a group called the Infrastructure Asset Data Dictionary for the UK, which is looking at what I believe is one of the major stumbling blocks we have with all these deliverables. Over the last 5 years, we've done some amazing things to help us to manage, classify, control, authorise, assure, secure and transmit our information. Much of this work has become a British standard and will become an international one over time. But we have a problem, a fundamental issue that means the client isn't getting many of the benefits they ought to. The information we are managing, classifying, controlling, authorising, securing, assuring and transmitting is exactly the same data we've had in our systems for many years. And we've been asked to make good decisions on important issues like social, economic and environmental impacts. We've been told that we can achieve great things and savings between 20 and 50%. Okay, so we may now have better reliability and assurance for our information we've always had access to, but we need more information to help us answer critical questions throughout the life cycle of the asset. Those critical questions aren't just about design, construction or maintenance issues. They impact every stage of our asset's life cycle, and the sooner we start making good decisions, the greater our benefits are as we move into the future. This diagram shows the suggested data drops for our assets at every level throughout its life cycle. We start here at ops and maintenance because most of our assets are at least 100 years old. The observations we gather at this moment in time tell us whether the asset is still operating and performing as it was designed, and whether there are any maintenance issues that cannot be overcome through day-to-day repair. These observations, combined with the financial and political information, are used as the basis for a strategy, whether we should replace, dispose, upgrade or augment the existing infrastructure. This strategy is then combined with information on existing assets, such as documents, data, metadata, CAD, etc., and the contractual package that forms the basis of the project information model. Next, there are questions that need to be answered which help us to decide which concept delivers the best social, environmental or economic outcomes. The next set of questions are all about how to meet the brief in detail, specifying the exact requirements and functionality for each asset. Construction questions are based on the practicalities of turning a virtual asset into a physical one, and incidentally, the first time we should be looking at specific products. The engineering carrying out the commissioning will ask about the tests needed to ensure the equipment meets the specification made in the design. When the final handover happens, the main question will come of how we get the information from the project information model into the asset information model. Those operating our asset will want to know the most efficient and safe ways to operate the equipment, and what its functional specification was to ensure that they are using it to its optimum capacity. When the maintenance crew are called in, they will have multiple questions on things like what tools to take with them, what PPE to wear, and where to find the method statement, as well as what they are looking for to grade its condition. Inevitably, at some point, we will need to decommission the equipment and replace it with something that meets the same functional requirements that we specified earlier. The information to answer our questions here will actually have already had an impact when we were deciding what to specify and purchase. And finally, the data drop we all hope doesn't happen. I don't want to waste time searching information when the worst happens. If my equipment catches fire, I want to instantly have the answers to the questions. So what do we define as an asset? In generic terms, we describe an asset as a physical thing that delivers a function or a supporting function, i.e. a structure, a manhole, permanent way, safety barrier, earthwork. You'll notice that the structure and earthworks asset examples are made up of multiple assets which form functional groups, and we record assets down to the level we expect to maintain them. So a window is an asset, not the sealant, the glass pane, the hinges or the locking mechanism. That functional group is made up of lots of smaller functions, such as this embankment, which is made up of all the individual elements. To help us put a structure to our infrastructure assets, we need to look at them in this way. At the top of the tree is a complex, a network, if you will, of all our assets. This could be a road, a rail, a power or a water network. That complex is made up of multiple facilities. In highway terms, these are the roads and the junctions that go between them. Slightly easier to understand with rail, these are the lines and the stations, but in simplistic terms, they are hubs and connectors. The facility has multiple entities along it that carry out functions, such as taking the facility over a river, providing lighting, imparting stability or drainage. These entities are made up of elements, which are the lowest level of the maintainable asset. So in this example, we have an erosion control element of an earthwork entity, which is carrying out a function along the M1 facility, which is part of the Highways England complex. Simple. At facility, entity and element levels, we define that function as a tag, alongside a whole raft of other information that are represented by this diagram. It's made up of the following. Firstly, what type of thing am I? Secondly, what function do I carry out? Then, what functional grouping do I belong to? We look at what questions I need answering at every stage. Where does this thing carry out its function? How it's identified? And finally, this tag will be fulfilled by a piece of equipment or material. That asset information requirement that answers the questions comes in the form of an Asset Data Dictionary definition document, or AD4 for short. It's actually not a document, but more of a database, really. This AD4 describes the asset at facility, entity and element level, defining the types of asset, the functions and classes that relate to them, the attributes derived from the plain language questions asked at each stage, for each task at that stage, and by each discipline involved in those tasks. Importantly enough, it also tells us what each of those attributes mean. We shouldn't confuse these with product data templates, as these talk about the equipment, not the function. So let's briefly look at an AD4 at facility level. This gives us a high-level definition of the class and the function, either a node or a connector. A standalone building could be a node in a bigger campus complex. This will list the possible entities that could be found as part of this high-level functional group and the attributes that will help to answer the questions at every stage. It should also include naming conventions and a worked example. Below that comes the entity level AD4. This gives us the functional grouping and the class at this level. Whether it is a node or along a connector, there will be multiple entities, which could be structures, earthworks, minor junctions, gantries, permanent way, pavement, etc. And this will list the possible elements that could be found as part of this functional group and the attributes that will help to answer the questions at every stage. It should also include naming conventions and a worked example. At the maintainable level, we have the element AD4. Once again, this gives us the function and class at this level, the attributes that help to answer the questions at every stage, how it should be named and physically labelled. It will also give some visual examples, as a picture paints 1,000 words and helps to bridge the language gaps. And finally, the performance and replacement triggers. So that's a huge task. Where do I start? We were inspired by a city council on the other side of the world that has achieved some amazing things with their asset management. They started with looking at questions. Luckily for them, they had a wealth of questions that were posed by their operators and maintainers over many, many years. These questions were worked over by a team of data analysts to create a set of critical questions that were used to generate the asset information requirements, followed by a resurvey of all their assets to ensure they had up-to-date and reliable information to answer the questions. This formed the basis of the method we advise today. That is to create a matrix with all the relevant life cycle stages, identify every activity that needs to take place at that stage, and the disciplines involved in the activity. The lead person of that discipline will have questions which need to be recorded along with how the answer is best expressed. Each question may need multiple pieces of information to answer it, but these pieces of information are what form the basis of the AD4 for each facility, element and entity. These of course are now federated together to form the basis of an asset data dictionary, which is your AIR. So let's look at that earthwork example. Some of the questions that might need answering could be: what are the carbon or ecology targets? What are the existing geology or borehole information? What does each option deliver in cost, carbon and environmental impact? What is the function and how does each element federate to deliver that function? How is it constructed? What are the slopes, angles, elements, materials, equipment, planting? How do I test to ensure it's delivered the function promised? What is the water runoff? Optimum growth for plants? What is the compaction? What are the slump tests? What's the slippage? How do I access for work? What will be the geotechnics and the disposable materials? And finally, what happens if there's a flood or a fire? You will also need to think about information that won't be on the tips of everybody's tongues, such as the criteria for replacement. This covers things like the cost of labour, hiring of equipment, consumables, and the possession or shutdown costs. Ideally, this is a live link to an ERP system, as it needs to be live, up-to-date information. When we defined our function, there was a minimum performance criteria set that if the equipment or material fulfilling that function drops below the accepted standard, it will trigger a repair or a replacement activity. These criteria would ideally look at things like energy consumption, maintenance frequency, acceptable condition, and anything specific to that piece of equipment or material. In an ideal world, many of these triggers will be remotely monitored through sensors or drones, taking the human element out of a dangerous environment. Through all these questions, it is very important to ask the person who knows best. So if we're looking at maintenance questions, we won't talk to the designer, and if you want to know how to operate it, you're not going to talk to the guy who constructed it. So if we have all this information, our replacement criteria, our expected performance, our critical information, we can start making better decisions that are going to deliver those efficiencies and savings we're all striving for. The Infrastructure Asset Data Dictionary for the UK group was set up to share this knowledge and perhaps also bring together the major infrastructure owners into the benefits of using a common asset data dictionary between them. Working together to create such a database can only reduce the cost and burdens. So imagine, if you will, a single asset data dictionary for the UK owned by the UK clients. Every project, no matter who the client is and no matter who the contractor is, will require the same basic information. This will help both sides to better estimate and compare the costs of information, helping the supply chain to deliver a single set of information for what they build, fabricate and manufacture. If there is only one set and format of information needed, then suppliers' online databases may only need to present one set of information one way. Each data drop is a standard set of expected data, reducing the risks of translation and conversion. If we create a new asset that crosses multiple owners' assets, such as HS2, the data coming in will be what is expected and will easily feed into the client's asset information model. We can standardize what information is relevant from the remote sensors, and potentially this could break down the interoperability issues which we currently labour under. Across multiple asset owners, we can better compare the performance of our assets, and finally, we can reduce the risk and costs of information we need to deliver those government targets. If you'd like to know more information about the Infrastructure Asset Data Dictionary for the UK group, or wish to get in contact about any of the things that we've discussed previously, please do get in contact. My email address is here and also my LinkedIn. Thank you.